Okay, hello and welcome to our video on predicting the products of chemical reactions. Question for you, what do you call a test tube that got its degree? A graduated cylinder. Huh? 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 Hmm. Okay, I get it. No, still, let's move on. So, I've shown you this video before, actually. This is the super cool video of what you get when you add a little potassium iodide, that's what they're stirring right there, to some lead nitrate. So lead 2 nitrate is added, and it comes in looking clear, and all of a sudden you get these crazy yellows forming. Crazy yellow swirly gunk. Here, you can watch it. And, oh, it's raining down. What? And it happens instantaneously, right? So, kind of cool. How can we tell, just from looking at this that it's lead nitrate and potassium iodide, how can we tell we're going to get that yellow gooey stuff coming out? Let's look at it. Okay, so this is the situation, right? You've got two known reactants. We told you that you've got this lead nitrate and this potassium iodide coming together. What is that going to form? Well, it might help if we color-coded things a little bit. So remember, these are ionic compounds. We can separate each ion by color. So I just happen to have put the ones that are kind of inside together here in orange, and the ones on the outside green. Why? Because they're going to swap places. This is a double replacement reaction. So what you can see is the greens come together and the oranges come together. So the lead and the iodine, right, form PbI2. So they come together as a compound, and then the potassium and the nitrate form KNO3, potassium nitrate, over there. And it so happens that, sorry about that, this right here, this lead iodide, that's the yellow gooey stuff. So how did we know that was going to happen? Well, we can predict the outcome of reactions by doing a couple of things. And we're going to really only focus on single replacement and double replacement reactions. Here, you'll predict more in your chemistry class. So first, what we want to do is recognize the ions involved in each compound, right? We're dealing with ionic compounds that can come apart as individual ions. And then we're going to recognize that a metal is going to replace a metal and a non-metal is going to replace a non-metal, right? You don't really get it the other way. A metal is going to jump in the place of another metal and take away that ionic bond it had with a non-metal. We're going to make new compounds with a little drop and swap action, which we've done plenty of times before. And then we're going to learn about something called diatomic atoms. It's actually very simple. It's just that when certain elements hang out by themselves, they can't hang out solo. They got to hang out with the twinsy. Okay, so we need to recognize the individual parts of the compound. So remember, chemical reactions involve rearranging atoms, and what we need to do is look at these compounds and recognize they can come apart, right? In a single replacement reaction, you've got a compound, AB, right here. And the A and the B can come apart so that the A joins with the C in this new compound AC, and B ends up by itself. We need to see these as individual parts that can come apart and then mix back together into different ways. So here are some examples of ionic compounds doing that. These are all ionic compounds: NaCl, sodium chloride, K2SO4, potassium sulfate, and CuCl2, that's copper 2 chloride. And so we hopefully can recognize that they are made up of individual ions. So this is a sodium ion and a chlorine ion, a potassium ion, or two of them really, and one sulfate ion, a copper ion and two chlorine ions. So this is really what they kind of look like if we think of them as ions, right? We got a +1 sodium ion. We got a -1 chlorine ion. How do I know that? Periodic table. We got a +1 potassium ion. Know that from the periodic table. We got a -2 sulfate ion. Know that from my polyatomic ions list. We've got a -1 chlorine ion and a +2 copper ion. How do I know this one? Copper is a transition metal. I know it has a 2+ because to balance out the two -1 chlorines, right? So that was CuCl2. Oops. Right, CuCl2, that means that there's a total of -2 over here. We got to balance it out with a +2, so I know that's copper +2. When I see these as ions, I can now figure out what they're going to do when they rearrange after a reaction. The second thing to remember is that when we have these replacement reactions, metals replace metals and nonmetals replace nonmetals. And so this is really what happens. You've got ions of some of these metals hanging out, and they rearrange and put themselves in new places, taking the place of another metal. When you get to chemistry, you'll actually come across a way to figure out whether or not it's going to happen. It doesn't always happen. It depends on which metals or nonmetals we're talking about. There is a way to predict that. We're not going to get into that in this class. I'll just show you that all of them that are going to do it. So here's an example. PbCl4, that would be lead 4 chloride, and some F2. F2 is fluorine gas, right? Which is super, super nasty stuff, as you might remember from having seen that before. They're going to be in a single replacement reaction. And I've highlighted in red the nonmetals, and in blue, or cyan, if you will, we got the metal, right? So the nonmetals, the nonmetals are the ones that are going to swap places here. And so what you can see happens is that the F, the fluorine, matches up with the lead to become a new compound, and the chlorine ends up by itself. So the metal remained in the compound, right? It's a compound of lead in both cases, but these nonmetals switch places. Okay, then we really need to remember our drop and swap, right? So we're going to be basically making new ionic compounds. We need to figure out how to make them correctly, and that's what our drop and swap is all about. So remember drop and swap. Here again, let's say we have some barium and some chlorine, and they're going to come together, right? Barium forms these +2 ions. I know that from the periodic table. Chlorine forms these -1 ions. I also know that from the periodic table. The numbers are going to drop and swap simply to tell us the subscripts. So the charges don't come along. This is a shorthand way of helping us figure out how to balance these and do it faster. It is not about moving the literal charges. So we simply take the 2 that was up here for barium and slap it in front of the chlorine as a subscript, and we take the 1 from chlorine and slap it in front of the barium, and of course we don't need to write 1, so we just leave it out, and it becomes barium BaCl2, that's barium chloride. Pause the video if you need to catch it up in your notes. Okay, here's another example. So this is getting back to that reaction I showed you before. So we had PbCl4, right, iron 4 chloride. So chlorine forms -1 ions. How do I know this? I know this from the periodic table. That's where chlorine is. I know it's going to form -1 ions. There are 4 of them in the compound. See the 4? That means it's Cl4, so the negative charge in the compound is -4. That means that to make the compound neutral, which all ionic compounds are, the lead ion must be +4. So I've just figured out that charge on the lead is +4. When I make that new compound, the lead with the fluorine, I know that I'm bringing in a lead ion with a charge of +4. And I also know from the periodic table that fluorine, the F, forms -1 ions. So to make the compound neutral, we need 4 fluorines, right? It might have been different if we'd used something that formed a different ion, but fluorine forms a -1 ion just like chlorine. So we put 4 of them there. That's 4 -1s to match up with the +4 coming in from the lead. Okay, the last little thing you need to know for these predicting reactions thing is called diatomic ions. And this is actually a fairly simple concept. There are 7 elements that when they're by themselves, when they're not part of a compound, they're only found in bonded pairs, right? They basically always need a friend. And these 7 are hydrogen, so right here. And then so they're all nonmetals, hydrogen, and then some of our more common nonmetals as well, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So these is, if you have a reaction where these guys come off, right, and they end up as the solo one, they are no longer part of a compound, you got to put them in as these 2s because they just live that way, right? They live their lives when they're not part of a compound, they live their lives as these diatomic ions, di meaning 2. So they got to be 2 atoms of the same thing. Okay, let's look at an example. So we're going to react some gold, Au, with copper 2 chloride. That's what this is, copper 2 chloride. And what is going to come out of it? Well, let me first highlight the different kinds of ions. We've got 2 metal ions here, the aluminum and the chloride. I'm sorry, that's not supposed to be Au, that's supposed to be Af. That's a typo. Al plus CuCl2. So that means that we know the metal is going to replace the metal, the aluminum is going to replace the copper, and then the chlorine is going to stay in the compound. Let's take apart the ions. So aluminum forms +3 ions. We know that from the periodic table. Chlorine forms -1 ions. We know that from the periodic table. And this copper is a transition metal. It's going to form the +2 ions because if we go back, you'll see there's 2 of these -1 Cls there. So to balance that out, the copper has to have a +2. So +2 and a minus there. And so what we're going to do is we're going to flip-flop these 2 metal ions, and we got to make new compounds that work. So see, we're flip-flopping the aluminum and the copper. And so the copper comes out by itself, and copper is not one of the diatomic ions. We can say Cu, it's just by itself. But then we got to drop and swap because we have a new compound we're forming out of aluminum and chlorine. So we give we take the 1 from the chlorine and make that a subscript for the aluminum, and the 3 from the aluminum and make that a subscript from the chlorine. And so that gives us AlCl3. Remember, there would be a 1 there, but we don't write 1s down. So the products are copper and aluminum chloride, or AlCl3. And then we got to balance it. So just looking at the fact that there were different numbers of chlorines on both sides, I balanced it by putting in some coefficients there. And you can see now we have 2 aluminums on both sides, 6 chlorines on both sides, and 3 coppers on both sides. Okay, now is one to try yourself. So we've got sodium carbonate, Na2CO3. CO3, remember, is a polyatomic ion, and magnesium chloride, MgCl2. So you're going to try to figure out what's going to happen with this. Hint, it's a double replacement reaction. Pause the video, try it in your notebook. Okay, welcome back. Hopefully you figured out that the red ones are going to come together and the blue ones are going to come together. So when the blue ones come together, that's a +1 sodium ion and a -1 chlorine ion, and that's good old NaCl, or salt, table salt. And then the magnesium and the carbonate are going to come together. If you look up carbonate on your polyatomic ions list, you'll see it's a -2. And so the magnesium forms a +2, and so they would just balance each other out if we do MgCO3. All right, so that's it for predicting reactions. I hope that makes sense. It seems daunting. It's actually fairly simple. You're just trading places in some ion. So give the rest of the work a shot. It's been great talking to you, and I will see you in the next video.